At this time, I'd like to introduce our presenter, Mr. Todd Alford, our Commercial Marketing Manager for System Sensor. Todd?
All right, perfect. Thank you, David. As David mentioned, this webinar is geared around, or we're calling it the Meet the New Problem Solver Advanced Multi-Criteria Fire Detector. So when we introduce with something like that, that begs some questions. What is the problem? How does the Advanced Multi-Criteria Fire Detector solve those problems? So the first thing we'll do, we'll actually start out with a case study, a recent example. That'll give us a little context as to why this new detector technology is so helpful and so important. Then we'll look at the overall problem that drove the development of the detector. And then after that, I'll describe how the Advanced Multi-Criteria Fire Detector solves that problem, how it works, and then we'll actually get into some of the technical details. Then I'll provide just an overview of some of the ideal applications for this technology. And then finally, at the end of the presentation, even though, as we mentioned, we encourage you to ask questions throughout as they come up so we can address them specific to the topic we're talking to at the moment. But at the end, we'll still try to reserve some time for open questions and answers. As David mentioned, you can type them into the chat feature at any point during the presentation. David will potentially interrupt me during the presentation to answer some questions right away. Anything that we don't get answered during the presentation we'll pick up at the end. So let's take a look at the case study before we dig into details on the product itself. So just as a preface, I'm sure many of you who've done system installations, you've come up against challenging fire system applications that either tax the capabilities or performance of the traditionally available smoke detection technology. In fact, it can get so bad that the detection system, in the case we're showing here, can actually become a bit of a liability. And that was the case with the Rumba Room. This is a Hollywood, California nightclub. It's part of actually a large entertainment complex with interconnected buildings and facilities. And the club itself is a two-story, 25,000 square foot club on an average Friday, Saturday night. They've got 1,000 people in there. They've probably got the velvet rope outside with people standing in line waiting to get in. Multi-level dance floors, and they do the full laser light show, bring in a lot of that theater smoke and fog effects. And unfortunately, it was that introduction of the theater smoke and all that fog that was triggering nearly a nightly nuisance alarm in the building with their existing photoelectric smoke detectors. So they tried to fix it. They had different vendors coming in telling them, well, use this technology of theater smoke generation. It won't disturb your, we've tested it. It doesn't disturb traditional smoke detectors. This will work fine for you. And invariably, everything they tried, they'd still end up with nuisance alarm. They'd still end up evacuating not only their facility, but the adjacent attached facilities. So each alarm could end up resulting in 1-2 hours of downtime in which that facility, the connected restaurant, other adjacent spaces would have to be evacuated. And in a complex like that, the lost revenue from each instance could exceed tens of thousands of dollars. So ultimately, what they elected to do, or got permission to do, were to set all of the smoke detectors in that area on supervisory mode, allowing them the opportunity to investigate when they did receive an alarm, allowed them to investigate first before the fire brigade actually came out to respond to the fire. But obviously that slows the fire response in a real incident and opens up the door to additional liability. So it's really not an ideal solution. So in 2009, Calide Technical, that was the system designer who was brought in to upgrade the fire safety system for the entire entertainment complex. They came out, and when they saw the Rumba Room, they recognized that that posed a particular challenge for the new fire system, and they really felt that keeping the fire system on a supervisory mode was really unsatisfactory, really not what you'd want to do, both in terms of liability and the cost to the resulting delay in actual fire response, where they'd receive an actual fire event and it wasn't the result of a nuisance concern. So they suggested installing about 25 of the new advanced multi-criteria fire detectors covering the entire dance floor area because of their ability to respond to actual fires but maintain high immunity to the type of nuisance conditions that were present in the space. So while the detectors themselves are about 15 to 20% over the installed cost of a traditional photoelectric detector, the Rumba Room owners agreed that with 1 hour of downtime saved, I mean, at the nightclub, that would more than 50 times make up the difference between traditional technology and this new advanced technology. So after the installation was completed, they were actually able to return all detectors back to alarm mode from supervisory, and they've been running at least 3 months now without a single alarm. And actually talking to our regional representative in the area, the complex owners are actually so happy with the outcome that they've suggested they'd like to see the advanced multi-criteria detector now actually installed in other areas throughout the facility, not just in this particular problem area. So the nightly nuisance alarms, completely taken care of by the new detection technology, and again, they're able to operate in full alarm mode and run their club the way they want to run it with all the smoke and light effects and all that good stuff without any disruptions. So I think, yep, at this point we take a little pause, and David's going to introduce our first poll question.
You bet. Thanks, Todd. So the question is, in what percentage of your projects have nuisance alarms been an issue? If you could select one of those categories, I know it says all that apply, but if you would just please select one, so less than 10%, 11 to 25%, 26 to 50, or greater than 50. A number of you have voted here. Let's give you about another 5 seconds or so if you would. So please select one. Okay, let me close the poll, and we'll also publish those results so you can see how you and your peers may be facing here. So, Todd, about a little more than half that are indicating less than 10% of nuisance has been an issue, 11 to 25%, 31, and then the last two categories about 8%.
Okay. All right. Fairly consistent with what we've seen on other.
Sure.
All right. Then I think I'll move forward. There we go. All right. So on the next step here, then let's take a little bit a deeper look at this nuisance alarm issue. And that's really what the advanced multi-criteria detector is designed to solve. And the problem itself, the nuisance alarm problem, is that the fire system applications that stretch the capability of traditional fire detection technologies, resulting in nuisance alarms, somebody needs to come up with a solution for that. Traditional fire detection technologies, your typical ionization, photoelectric, photothermal, even some of the basic multi-criteria detectors that are out there, essentially are trying to balance two competing needs. You want to have a rapid response to a real fire situation, but at the same time, you also want accuracy. And unfortunately, the norm was increasing the performance on one aspect ends up reducing the performance in the other. So improving your response time ends up leading to unintended nuisance alarms. And in the same way, trying to put in some filtering to reduce nuisance alarms typically leads to an increased response time, which is undesirable. And when we talk about applications and the types of challenging environments in which we deal with these situations, we can break them down into kind of two main categories. And the first are those that just by design or inherently have nuisance conditions present that tend to trigger nuisance alarms in traditional technology or detector technologies. So, the theater smoke in the Rumba room example is a perfect example of that type. Others might include, hotel rooms where they're adjacent to, the bathroom, or the detectors adjacent to the bathroom, and shower steam creates nuisance concerns. Welding in a factory or industrial application, or smoke and fire near a kitchen environment, all areas where you expect to see those type of elements present, but you still want to provide good detection, and you're balancing those competing needs. The second kind of area of challenging applications would just be those that, while they're not necessarily prone or inherent to having nuisance conditions present, they're the type of facilities they can't tolerate disruptions at any cost, whether it's a nuisance alarm or some other reason they can't afford an interruption to their operations. So for those applications, a nuisance alarm would interrupt a mission-critical activity. It could pose a significant threat to life safety. And examples like we show on here would be, a financial trading center where they're doing real-time trading, data centers, or any medical-related field, hospitals, medical research, et cetera. And we'll get into a little bit more of that later in the discussion. But those are the kind of the two primary categories for challenging to traditional detector technologies. Further outlining the problem, false alarms in general are a widespread problem. They still represent about 1 out of every 10 calls to the fire service in the U.S. And then if we break that down a little further and go to the unintentional false calls, and we filter out all the the malicious pulling of pull stations and that sort of thing, and filter it down just to the unintentional calls, it still represents a third of those. So out of the 2.2 million calls to the fire departments in 2007, about 75,000 of those calls were false calls, probably related to a nuisance concern or an unintended activation of a detector. And then furthermore, the newer construction materials and furnishing materials that have come into play over the last few decades have been shown to increase fire acceleration. So, the historic NIST study, typically referred to as the Indiana Dunes study, they looked at this back in the 70s and then took a kind of a refresh of that study back in 2003, and they basically found that as we've moved away from natural fibers like cottons and wools and into the more man-made fibers and materials, the advanced resins and glues in the building materials, as well as the orlons and polyesters and nylons in fabrics and carpeting and floor coverings and so forth, the detection technologies that have been present for this same time period work very well. They detect the fire well, so that this isn't meant to say that photoelectric or ionization technology doesn't work. They respond very well, but the difference is that the fires propagate so much faster in these new materials that your escape time is reduced. So obviously, one solution to that would be, well, let's make the detectors more sensitive so that they respond sooner and maximize our response time. But obviously, as we mentioned before in the previous slide, or one of the previous slides, is that as you try to increase your sensitivity, you also open up the opportunity for more nuisance alarms. So let's take first a look at how the different fire types contribute to a problem, and that's what we're trying to depict here. Among other products, all fires produce smoke. They produce heat. They typically produce carbon monoxide, and obviously once they reach the fire stage, they produce a recognizable light pattern. However, depending on the fire type, the material that's actually burning, those elements will be produced in varying types, in varying amounts, and they'll appear at different times during the development of the fire. So as this graph is showing, a heat detector might excel very well at detecting a flaming alcohol type fire, a very hot, very rapid fire. They would have a very poor or slow response to a smoldering fire, like you would see from fabric starting to smolder, or a wastebasket fire. Similarly, ion detectors, they've been known to be very sensitive to the more fast-flaming fire, while the photoelectric detector is tended to be felt to be more appropriate for those slow smoldering, slow building fires, to where now we're seeing, at least especially in residential applications, the recommendation that the combination of ionization and photoelectric be installed. But so there's these multiple detector technologies available, and each of them excel in certain areas and then underperform in others, becoming either less accurate or less responsive to certain fire types. So the question is, well, how do you choose? And again, that leads to the recommendation to put in combination technology into, again, especially toward the residential side of the world. The latest pitch has been combination ionization and photoelectric. But again, that's still a compromise. So because the costs and dangers associated with nuisance alarms and nuisance alarm avoidance are so significant, System Sensor a few years back invested a great deal of time and resources in trying to develop a real solution to the problem. And our approach was use our knowledge of the products of fire, the studies we've done to develop our products, to create an array of sensors that not only covers all types of fires, but in conjunction with sophisticated algorithms to communicate between the sensors, it really pushes the corresponding boundaries of fire detection and sensitivity and accuracy to levels that haven't been available to us with existing technologies. So that brings us to the product itself, and that's the Advanced Multi-Criteria Fire Detector, and we unashamedly say it is the most accurate fire detector in the world. We built this product specifically to meet the requirements of the most challenging applications. And if you remember this chart, we showed the balance between sensitivity and accuracy. Well, essentially, you can forget about it. It really doesn't apply to a product that works the way this does. Because it can be highly accurate and highly sensitive and provide the fastest response to real fire at the same time as being immune to typical nuisance concerns, you're really getting the best of both worlds. You don't have to, play this balancing game anymore. So how does it work? The detector itself combines 4 detection methods in a single housing. It's designed to measure all 4 products of a fire: heat, smoke, carbon monoxide, and light. And really, having that combination of sensing technologies in one device is a first in the industry. If any one of those sensors detects a fire condition, the onboard intelligence verifies that condition with one of the other sensors before generating an alarm. And then finally, the CO sensing cell that's built into the device, this is one point we want to make sure we are clear and people understand. It's deployed as a component of the fire detection. It helps this device be a very accurate fire detector or smoke detector. So the device itself is not listed for standalone NFPA 720 type carbon monoxide detection for life safety. It's a component of the fire decision criteria algorithms. But coming back to it, so these 4 sensors, they're working together to enable the detector to respond to multiple fire types in the widest range of applications and reject nuisance concerns. And none of that would be possible without the intelligence that guides all the pieces to work together. So there are onboard algorithms built into the product itself, processing that takes place on board amongst the 4 sensors to help make the right decision. So it's using a powerful central processing unit that has the built-in algorithms that provide things like extended drift compensation. It allows it to vary the sampling rates, the alarm delay, and the sensitivities, and actually real-time adjust sensitivities based on the current environmental readings. It's the result of years of research and then extensive testing. The dynamic adjustment that it automatically does, it allows it to operate very much at a high immunity level, so that rather than setting it to a specific level suited to the environment, you can actually set it to what's suited to your application. It will normally operate at a very high immunity level, but automatically become very sensitive to fires once the proper characteristics are sensed. And I think the best way to describe that is via an example. So if you had a baseline or a regular photoelectric detector installed in a space, you might have a baseline sensitivity to set to, say, 3 or 4% per foot of smoke as a response point. If you were to install the advanced multi-criteria detector in that same application set to kind of the same operating parameters to operate or respond at 3 or 4% per foot of smoke, the difference between the 2 devices would be, as particulate is sensed and it starts to recognize, hey, I'm starting to see a level of smoke in the space, how do I want to respond to that? Your traditional photoelectric detection technology is not going to respond until it reaches its threshold, that 3 or 4% per foot of smoke. However, with the advanced multi-criteria detector, if it starts to see, let's say, 1% per foot of smoke, but it's also seeing a corresponding rate of rise of heat, or it's seeing a buildup of carbon monoxide that matches what's been programmed as and modeled as a real fire characteristic and situation, it's not going to wait until it reaches that 3% threshold. It will actually automatically change its sensitivity to respond much faster. So again, you get that best of both worlds type scenario where I can set it for what's appropriate to my space, but to avoid nuisance concerns. But at the same time, if I see the right combination of elements that I know that the device knows this is not a nuisance concern, it can actually respond much faster than traditional technology. And I think, yep, this is our next pause point for a question. So I'll turn it back over to David.
Thanks, Todd. Would this unique set of detection technologies enable you to out-specify your competitors? So if you would make one selection there, yes, it would, or no, for a variety of reasons. No, we don't get involved in spec writing, or competitors can easily modify specs, or no other. If you could vote, we'll leave it open for a few more seconds. There we go. Looks like a majority of you have voted, so I'll go ahead and close the poll and then share the results back with you. Looks like, yes, Todd, 68% have indicated that it would allow them to outspecify competitors.
Okay, great. All right, with that, I'll pick back up here, and we'll just continue on a little bit with the configuration and operation of the device. Installers can set the alarm threshold to up to 6 different levels to match the environment in which it's installed, anywhere from a very clean room environment where you might want a higher sensitivity as a baseline to a harsh mechanical room or a food prep area where, again, you're trying to maximize that nuisance alarm resistance and set it to a higher obscuration or less sensitive setting. So the detector senses fire is really in the widest range of environments. It provides that best immunity to nuisance alarms, and that's what makes it ideal to those applications that traditionally have proved challenging for traditional technologies. So how does it perform compared to other detection technologies side by side? We actually conducted an extensive comparison study that measured the performance of the advanced multi-criteria fire detector against ions, another multi-criteria that used just a combination of photoelectric and thermal, in a wide-ranging series of actual fire tests and challenging non-fire nuisance scenarios. And rather than test this in the traditional UL fire test room, which is a very large space that really almost any detection technology would do fairly well in the nuisance concerns, because the space is so large, the actual nuisance products, by the time they made their way up to the detector, pretty much any detection technology would take a long time to pick those up and look like it was performing fairly well. What we actually did was we built a room within our fire test room that mimicked the dimensions of more of a typical space, normal ceiling heights, normal room dimensions, not a 30 by 25 foot room with 18-foot ceilings, so that we could present number one, something more reflective of a typical installation, but secondly, to provide as challenging an application as possible for traditional detection technologies in a nuisance scenario. So, as we flood it with steam or theater smoke or, overdone popcorn in a microwave, those type examples, we'd be very likely to really test the limits and capabilities of traditional technologies against the advanced multi-criteria fire detector. So let's look at how that worked out. Our testing actually included 21 different nuisance alarm tests and 29 real fire tests, including flaming fires, smoldering fires, and then on the nuisance alarm tests, the way we measured this is on the nuisance alarm side, we rated the detectors to perform well based on how slowly they responded or how long it took them to respond. So, the longer it took to respond or recognize that or mistakenly recognize that a nuisance concern was a real fire led to a better score. And then for the fire tests, kind of the opposite. The faster it responded, based on the fact that it is a real fire and you want a good response, the faster the devices respond, the better their performance. And as we summed all that up, basically we wanted to force rank them to determine that the best performing detector overall would have to perform both well in rejecting the nuisance or taking a long time to respond to nuisance, as well as being very rapid or quick to respond to actual fire tests. Because in the real world, obviously, there's no point in having an extremely fast fire detection if you're going to pick up a bunch of false alarms, and conversely, having no false alarms, but also having slow or non-existent real fire detection. So if we look at the results, in the nuisance alarm tests, the advanced multi-criteria detector actually had a near-perfect score, indicating that it either didn't go into alarm at all or was at least the last of the devices to respond to a nuisance concern. And then in the fire test, the advanced multi-criteria detector was either the first to respond or responded within just a few seconds of any of the other detector types. It's also important to note that the detector outperformed competing detectors in all fire types. It outperformed the photo detector in the smoldering fires, in which that technology is typically felt to excel, and it outperformed the ionization detectors in flaming fires, in which that technology typically is viewed to excel. So next, we're going to take a look at some of the actual applications for advanced multi-criteria fire detectors and explain how you can communicate its value out to the key stakeholders.
Todd, we do have a couple questions from the attendees. Could we answer those at this time?
Absolutely.
Okay. The first question, again, if anyone does have a question, you have a hand symbol with the green arrow. That's a way to ask a question. Actually, that's a way to raise your hand, but you do have a question box that you can post a question. We encourage you to do that if you have a question as we go along. We'd love to answer those in as close to real time as possible. Todd, the first question is this product available directly from System Sensor or from one or more of the panel companies?
Okay, good question. This product is actually something that we OEM for different panel manufacturers. Right now, what I can tell you is that the NotiFire panel brand, as well as Johnson Controls and Honeywell Building Solutions, all have adapted their panels to accept this device. And we expect that Gamewell SCI will have their panel software updated next year to also be able to accommodate this device.
Okay.
So again, just very quickly, right now, immediately available through NotiFire, Johnson Controls, and Honeywell Building Solutions.
All right. The second question is on the CO component. They know that the CO component has a limited life, and what happens at the end of life of the CO component?
Okay. Also, a very good question, because that is correct. The technology that we've chosen for this is the same electrochemical cell technology that we use in our standalone carbon monoxide detector. And the reason for that is, of the three prevailing carbon monoxide detection technologies available, the electrochemical cell is really the most robust. It's not as subject to the effects of humidity, temperature inversions, that sort of thing that would cause false alarms or problems related to the CO component itself. So that's why we've chosen that. But one of the aspects of the electrochemical cell, it does have a limited life. It has a 6-year life. The way the advanced multi-criteria fire detector is designed, it actually has an integral timer built into it, so that at power up, it actually starts a countdown timer that will communicate to the panel that about 6 months prior to the cell expiration, will communicate to the panel that the cell is kind of reaching the end of its life. Then again, when the cell itself has expired, it will communicate that again to the panel. At that time, the device automatically reverts to a completely new set of algorithms based on photo, thermal, and infrared inputs. So you still have an extremely robust detector that just happens to recognize that the CO sensing element is no longer available. And then our plan for that really is we recognize or understand that most people expect that a detector should have at least a 10-year life. Our plan basically is to generate a one-for-one exchange program for customers who have installed this detector in their facilities. They reach that 6-year end of life, and they're not happy with just having photothermal infrared. They really want the full capability that they originally purchased. So a discounted replacement rate for a new detector to replace this one, giving them essentially a 12-year life out of the detector plus its replacement. And when we reach that point, we may actually be on to a next generation of this technology, and if that's the case at that time, then we would very likely just upgrade them to the next generation of this technology.
Okay. Todd, the next question is this detector listed with CSFM, California State Fire Marshals? So
it is. It is. We have both, obviously UL, we also have Factory Mutual, and it has its CSFM listing, and we're in the process of pursuing the ULC listing for Canadian applications.
Okay. I'll just take a couple more questions here if you don't mind, Todd.
Sure.
How would a tech test this device? I'm assuming a field application where they do an annual or biennial testing.
Yeah, and these are all great questions, because testing does come up very often when we present this product. People kind of wonder, well, how do you test it with all these different elements? The very simple answer is the only testing you're required to do is smoke entry testing to demonstrate that it's functioning properly through smoke entry testing is the testing of the photoelectric chamber portion itself, even though it has these other elements. I'll talk about that in a minute, but according to NFPA 72, if you have a multi-sensing or a multi-criteria detector, if there is a sensor that is essentially the primary sensor, which in the case of this device, the photoelectric chamber is the primary sensor, you have the ability to test or demonstrate the function of that component itself, that's sufficient to satisfy an FPA 72. So the way you would test it is, you initiate a test scenario or initiate a test mode via a magnet. So you bring the magnet up to the test point on the detector. What that does is that puts it into a mode where it's temporarily suppressing the inputs from the other elements, and it's responding for a period of time. It's responding to smoke entry alone. So that gives you then the opportunity to introduce aerosol smoke or one of the kind of a bowl-shaped or cup-based testing devices, demonstrate that it does respond to smoke entry, and then when you reset the device, it goes back to being a full multi-criteria detector. However, we also kind of recognize that some AHJs might not be satisfied with that. They'd like to see some of the other elements tested. And the way you would go about doing that, or one of the ways you could do that, is one of the testing manufacturers that I think is pretty well recognized within the industry, a company called SDI. They make the Solo tester, and again, I suspect a lot of folks are probably familiar with that brand. They've actually created a device called SmokeFire, which again is one of those bowl-shaped applicator type testing devices that actually allows you to introduce through they have built-in cartridges that work off a cartridge tape. They can introduce smoke, heat, and carbon monoxide either individually or so you could do that sequentially, or you can introduce multiple products at the same time. So you could introduce carbon monoxide and heat and smoke all at the same time within that confined chamber, and that would be a way to test that it is responding quickly to a combination of inputs. So again, this isn't meant to be an advertisement or anything for SDI, but they have developed that device specifically for these next generation of multi-criteria detectors that are starting to come onto the market.
Okay, thanks, Todd. There's a question about how UL views this detector. Is it viewed as a fire detector or a toxic sensor?
This is viewed as a fire detector. It's listed to UL 268.
Okay, all right. There's a question here. I'll go ahead and answer it if you don't mind.
Sure.
Do we have a sensor with a laser smoke detector? We do, and the individual who asked that will follow up with you afterwards with a data sheet that we do have for our laser smoke detector. Mm-hmm. Todd, there's asking for a comparison between the advanced multi-criteria detector and the simplex multi-detector.
I'll answer it as best I can. We're not 100% familiar, or I'm not 100% familiar with the sensing technology and the way the individual elements interact on the simplex multi-criteria detector. What I have seen is what they've done is they've incorporated a carbon monoxide cell, I believe it's also an electrochemical cell, into a sounder base, which allows you to then plug in either a photo or a photoelectric head into the base. And I recognize there's obviously some interaction taking place between those different elements, but I don't know enough about the sequence of operation and the algorithms built into that product to be able to compare it side by side with what this product is doing.
Right. I would encourage the person who asked that, certainly Simplex has a vast amount of information available on their products as well, and we can provide very good information as well on ours and just do a side-by-side comparison as you may need. Okay, Todd, why don't we continue on? There's a couple more questions, but we can ask them at the next break.
Okay, great. All right, so moving on to the application side of things. I mean, in the kind of the medical or, I guess the medical world, the advanced multi-criteria detector can provide value in a number of different ways. For example, in any medical facility, a nuisance alarm can interrupt. It could be interrupting a necessary procedure. It could be interrupting medical research, just common testing. And that could either create a life safety risk or potentially just the loss of critical data. An interruption to a common procedure can all of a sudden make them become more dangerous, more costly, and an interruption to some kind of life-saving procedure obviously could be catastrophic. So in a large hospital, an evacuation, That could be extremely dangerous for patients and staff. They might require moving patients from one area of the hospital to another where, they're not necessarily ambulatory patients, and you don't want to move them unless you absolutely have to. And then if you think in terms of, suppression systems and sprinkler activations that might be wrongly tripped by improper detection, that could needlessly damage very expensive medical equipment. And you should also note that certain surgical procedures can create nuisance conditions that could trigger nuisance alarms. So when you're talking to property owners, the emergency response coordinators, typically at a large hospital, you're going to have somebody who's kind of the dedicated emergency response coordinator. Or in the case of smaller operations like doctor-owned clinics, actually getting to the property owners, which may be the doctors themselves. Those are your key decision makers in those installations. And getting them on board, helping them understand what this technology can provide to them would be key to getting it specified into a product or into a project. So, when you're communicating the value of the advanced multi-criteria fire detector to these type of constituencies, you need to make sure you're obviously stressing the life safety issue, but also, query them and ask them about, the impact of a nuisance alarm or an unintended sprinkler activation or suppression activation, and what that would do to them from a cost perspective, either from the insurance side or from just a loss of equipment and life safety risk perspective. And they should be able to speak pretty comfortably to that. And that's a good way, again, to help them understand the benefits of this new technology. And then there are really two basic applications in which a financial institution might benefit from advanced multi-criteria fire detector. There are those that need to maintain a continuous operation of mission-critical processes, and then there are those that require protection of equipment assets, data, records, and so forth. So for the mission-critical processes like real-time day trading or real-time active trading, be sure to emphasize that detector can minimize the loss of opportunities and costs associated with missed trades or lost productivity, because obviously the stock market doesn't shut down just because they had at the Fidelity trading floor they had a nuisance alarm and everybody had to go to the parking lot. The stock market continues to move on without them, so they missed that opportunity to make trades at critical points in time during the operation or during the day's trading in the market, and they never get those opportunities back. So in that example, I mean, millions, even billions of dollars in transactions can be taking place every hour, and missing some of those opportunities can be detrimental and unrecoverable for those type facilities. And then even if a nuisance alarm interrupts the mission-critical activity of a trading floor, even for a short time, I guess we've made this point, those costs can ratchet up very quickly. On the assets and records side, the thing you'd want to zero in on is just the cost of first losing the equipment, the data storage, the servers, the equipment storing the data, but also the loss of the data themselves, especially, again, in the example of a unintended activation of a suppression system, but also just, in a real fire situation, you want that best, maybe it's not a situation that necessarily requires a high sensitivity detection system like we had the question about a laser-based detector that gets down to very high sensitivity detection capability. Maybe the space isn't necessarily suited towards that, but you do want the earliest warning possible to make sure that you have the most opportunity available to shut down equipment or take equipment offline before catastrophic loss of data and equipment happens. This detector could provide you that opportunity, whereas traditional detection technologies might not be as suited to that. Okay. In lodging applications, there's a lot of different types of suitable scenarios in which the multi-criteria fire detector could be used to eliminate nuisances. Some of them include, and we've mentioned these before, shower steam, where the detectors happen to be placed in an area that they're just subjected to that. So every time the bathroom door is open, they get flooded with that shower steam and go into an alarm, an unintended alarm. Patrons smoking in their room. Another example is in dormitories. They have a lot of the same similar characteristics. And in those cases, you want to talk to not only the campus fire marshal, because they typically have a lot of influence over the fire systems on campus, but typically the housing authority on campus is the one actually controlling the purse strings. So you want to actually get the ear of both of those folks and, explain to them or talk to them about the nuisance alarms that are, present either based on the same sorts of things you see in hotels like shower steam or students smoking in their room. The cost in traditional technologies, a lot of dormitories are still operating on single station smoke alarms, so they have the cost of battery replacement and lack of monitoring of the systems, whereas this is a fully monitored, addressable device, gives them point location of alarm, so they've got a much better handle on where a situation occurred and why it occurred, because, again, this detector is intended not to go off unless you have a real fire event, and it helps the emergency responders go right to the right location. And then finally, with part-time residents and limited access to some of those spaces in a managed apartment complex, and I'm thinking specifically of like the Floridas and the Phoenixes of the world, where they have a lot of part-time residents who are there maybe 6 months out of the year, but the remainder of the year they're back up north with their families. In a lot of those cases, they're starting to put in system-connected detectors, and what they run into is they get a nuisance alarm in one of those managed spaces, one of those apartment complexes, and they've got to find the building manager who's got a key to, a master key to get into that space, and they're, potentially disrupting the privacy of someone's space by getting in there when they're not present, just to investigate, why they had a smoke alarm or a smoke alarm event in that space. This device, again, is designed such that the only reason you should be seeing an alarm in that space is if there's something really going on there, in which case, the privacy matter is very secondary at that point. You need to get into that space because there's something going on in there, and you need to investigate it and either, extinguish a fire or resolve some other concern in that space. So, perfect for those type applications where, privacy and access to the space is more of an issue than it would be in, say, the hotel or dormitory type applications. And then finally, as we outlined with the Rumba Room case study, the advanced multi-criteria fire detector can bring exceptional value to entertainment venue applications, especially those that are including smoke, fog effects, anywhere they're using pyrotechnics. Another example might be, a traditional performance theater where they might put on a performance like a Phantom of the Opera, again, where they'll use that theater smoke. We've very often heard from our customers that in those type theaters, they'll actually put the smoke detection system that's over the stage area or near the stage area, they'll actually put that on a bypass so that they don't get false alarms during a performance, and then they're actually paying for a fire watch to be present during each performance. When you think about the cost of having a fire department personnel or somebody there acting as fire watch during each performance, the cost of putting in these detectors becomes very inconsequential as compared to paying for that, again, for every single performance. So when you're talking to, club owners or theater owners and operators, you should emphasize, the loss of business, the risk to life safety due to nuisance alarms, and in the Rumba Room example, they had a clear cost to both. And be sure to ask, do they already have a nuisance alarm history like they did with Rumba Room, and demonstrate to them how this can be a real problem solver for them and eliminate costs related to fire watch or evacuating a space that, was otherwise perfectly safe. And now we move on to, I think, our last poll question here, so I turn it back over to David. I think.
Yeah, sorry about that, Todd. The last poll question is, where have you had a need for a detector like this? You just saw 4 examples there: medical facility, financial trading, lodging and entertainment, or theater venue. Maybe it's others. So if you'd go ahead and vote, you can select all that apply. In this case, maybe you've had different installations. We'll leave this open for another few seconds to let everyone possible vote, and then we'll publish the results back to you. Okay, looks like we've got almost everyone. Thank you for voting. I'll close the poll now and share the results back with you. Todd, looks like medical facilities more than half, as well as the entertainment venue, with both financial trading and lodging coming in after that.
Okay. Okay. Good information. Thanks.
Todd, we do have a couple other questions. Could we take them at this time? Would you mind?
Yeah, let's do that.
Okay. The question came in, does this product come in a 2-wire, 4-wire, or addressable format?
This is only an addressable product specific to the panels that the panel manufacturers that we referenced earlier. So it's an addressable intelligent device.
Okay, all right. The next question is, can this, basically it looks like a retrofit application. Can this product replace a detector from another manufacturer in the future? And then, if yes, do we need to reprogram the control panel so that it can be recognized?
Okay, I think I understand the question. In terms of, putting this into an existing space with an existing detection, if it's, one of the panel manufacturers that, again, we talked about, either the Notifier, Johnson Control, HBS, and hopefully going forward here in the future, Gamewell FCI, if it's an existing installation, you would be able to basically take out existing detection technology. This device otherwise fits in the same bases, is configured the same way. The address setting on this device is via code wheels, so you can set the address to the device the same as the device you took out. And the one thing you would need to do on the panel side would be upgrade the firmware, download and install the latest version of the firmware that's designed to recognize this device. But otherwise, no new wiring is required. The only additional programming you would have to do is have the panel go out, recognize these devices, and then define the sensitivity, the baseline sensitivity of one of those 6 levels that we showed earlier on that chart for the device. But again, it doesn't require any new, tear up of the space or replacement of wiring and bases and so forth. They're designed to plug directly into any of the bases that our regular detection technologies currently reside in.
Okay. Next question is, how long has this detector been available in the market, whether here in the U.S. or elsewhere?
It has been available to the Notifier distributors for approximately a year now, and for Johnson Controls and Honeywell Building Solutions, about 6 months.
Okay. I think it's important to note that this product was originally launched out of our European facility as well, right?
Oh, good point. Yeah. As a matter of fact, it's been available in Europe now for probably over 2 years. So they actually, as a matter of fact, it was their R&D group working together with some of our folks who did a lot of the core development on this product. And part of the reason for that is while our whole industry here in the U.S. was working very hard to meet all the requirements of UL 9th edition, and that tied up most of the engineering resources, not just at our company, but at most of the panel manufacturers and so forth. The European team was a little bit more freed to use their resources to do things like this, and their goal was absolutely to make the best fire detector in the world, which, again, we think they did. And as the testing showed, we took a little bit of a not invented here syndrome approach and tested the heck out of the device to demonstrate that, yep, they absolutely nailed it.
Okay. Next question, Todd, is back to the laser question. Will this product be available with a laser version instead of photo in the future?
At this point, we don't have any intent to do anything like that. We are constantly looking at new detection technologies, whether it's laser for extremely high sensitivity or other means to detect the products of a fire. So while laser is not really on our radar for this product, down the road we absolutely have visions of incorporating other technologies either into this product or a future product that would continue to push the envelope of fire detection.
Okay. Next question, Todd, is specific application. Looks like the attendee has a question about gas turbine enclosures. Would this detector work in a gas turbine enclosure?
Yeah, I don't know that I'm particularly knowledgeable enough about what happens in a gas turbine enclosure, as far as what are the products of combustion in there, what elements the detector is likely to see in that environment to be able to answer that. But whoever's asking that question, if they could make sure they include that question on their survey response, we can get back to them and spend a little more time understanding that application and making a determination, would this product be suited to that, or maybe flame detection is really the only thing that works in that type of scenario. We just need to understand it a little bit better.
Okay. Todd, the next question is about cost. What's the cost difference between this new detector and a standard photoelectric detector?
Okay. As I kind of alluded to early on in the Rumba Room case study scenario, The actual landed cost of the detector is somewhere around 15 to 20% more than a traditional photoelectric detector. But when you're looking at the raw device cost itself, think in terms of about 2.5 times the cost of a regular photoelectric detector. But where that comes down to, that 15 to 20% is because you still have all the same junction box, conduit to run, wiring to run for both devices. So all of those fixed costs are still there. The only difference really is in the cost of the detector itself. So, that tends to, water that number down significantly. And then also, if you've got a large facility and you've only got certain problem areas in which you're installing this device, your overall cost to the project may be, 4 or 5% different, because otherwise, throughout the rest of the facility, traditional photoelectric technology works very well. There's no necessarily driving need to put in this better technology. You're only targeting this in those areas that really need it. So, yeah, it's adding 20% at this particular point, but throughout the rest of the facility, you're using, kind of more standard detection that further brings that down.
Okay. Good, Todd. There's maybe 2 more questions. Why don't you go to the summary, and then we'll answer those at the end.
All right, that'll work. So as we've kind of stated throughout, the product itself, the Advanced Multi-Criteria Fire Detector, it's uniquely suited for the challenging applications where either you, A, have nuisance alarms that are a problem, or you're likely to have a nuisance alarm problem, or B, where you just simply can't tolerate any downtime. So with the multiple sensors designed to recognize the different products of a fire, it can sense really any type of fire while providing the highest level of immunity to nuisance conditions. So your approach with the detector should be, first, get it specified. I mean, it is a unique detector. It has a combination of unique sensing elements and intelligence that can fit a host of challenging applications and really meet requirements that today traditional technologies just can't meet. And specifically, it's those applications prone to the nuisance alarms, or where they can be a threat to life safety, or where downtime is just financially burdensome. So the best approach, in our eyes, to getting the word out on this technology, and the one that's been proven so far, is to talk to the building owners that either have a vested interest in maintaining their operations, and there's always those folks that just have a very progressive attitude towards fire protection and have, of course, the applications that we've been through, any of those type of facilities. Those examples provided in this presentation talk to the folks involved with, and have a vested interest in maintaining the operations at those facilities, whether it's a dormitory, keeping a hotel up and running, keeping a medical clinic or a hospital up and running, getting at those folks and explaining to them the capabilities and benefits of this product and the potential life safety benefit as well as the financial benefit to maximizing your ability to prevent nuisance alarms and yet respond very accurately and appropriately to a real fire event. So that's our summary on the product. I put the last slide up here, David. I don't know if you want to go through this first and then pick up the last remaining questions, or if you want to go through the questions first.
Yeah, let's cover the questions first.
Okay.
There's a question here, a very specific question about the thermal sensor. Will it be possible to provide at the control panel a varying degree indicator in varying temperature indicator in degrees in response to the temperature reading changing in the actual fire scenario via the thermal element that resides inside the detector? Should we handle that one offline, or do you want to?
Well, I think I can generally answer the question. The thermistor elements in the device, while they're capable of reading back the almost in real time the temperature they're seeing at any given moment, the processing of that information is all taking place within the detector itself, and the detector is then feeding a composite signal back to the fire alarm panel. So right now, the only element that has any capability to give you kind of a real-time reading is the carbon monoxide element, and that was really done more. The fire panel manufacturers just kind of asked for that. We could actually provide the data from each of the individual sensor elements, but the amount of panel processing, if you thought about having 100 of these detectors installed and having 4 real-time pieces of data coming back for each detector, the panel processing there would be extremely complex and memory intensive. So the I guess the quick answer is no, it's not designed to work that way. All that processing takes place in the detector, and that discrete information isn't fed real-time back to the panels.
Okay. We do have a number of hands raised. That's all the questions that we have in text at this point. So
okay.
If you do have a question that you'd like to ask, we do have 3 hands raised. I'll go to each one of those now. If you do not, if you don't want to ask the question, or if it's already been asked, you can click that hand icon again to take your hand down. But we'll go to the first one here. This is Dale. And Dale, I've just unmuted your phone if you'd like to ask your question. Dale F.
I don't have another question.
Okay. All right. Thank you, Dale. We'll go to the next raised hand here, which is Michael. Michael W. I've just unmuted your phone. If you would ask your question, please.
Oh, you've already answered my question.
Oh, wonderful. We're 2 for 2. All right. And let's see. There is a third raised hand I have from Steve L. Unfortunately, you don't have your audio controls enabled. It's a 2-digit number with pressing the pound symbol, so I can't unmute your phone, unfortunately. If you would like to check that, and we can get your question asked, or you can post it in the question format in text as well. There is another text question. Todd, will this device be acceptable to use in elevator hoistways? And then, has there been any feedback since it was introduced in relation to this? So, elevator applications.
An elevator lift room, or as the Europeans call it, a lift room or lift control room, is one of the environments that this device was tested in. So, absolutely, it's suited toward that application, where you've got the metal particulate in the air from the elevator shaft tracks and so forth. It should work very well in that environment. Do I have specific feedback about a particular installation where that was done? Unfortunately, no, I don't. Our European colleagues might, but I don't know. Unfortunately, I don't know of a specific example. But in terms of suitability, this device should work very well in that application.
Okay. Let's see. Specific question again, reiterating about the panels that it's applicable to. You want to repeat that, Todd?
Sure. And I suppose I could potentially even be a little bit more specific. On the notifier side, it is their 3 9th edition listed panels. So it's their 3030 panel, the 640, and the 320 panel. On the Johnson Control side, it would be the IFC 3000, IFC 3030, IFC 640, and the IFC 320. And then on the Honeywell side, it's the XLS 3000 panel and the XLS 640 panel.
Okay. And there's a specific question to Siemens. Will this device be able to integrate with Siemens panels?
No, we don't have a communication protocol for Siemens that this device would operate under, I guess is the easiest way to put it. We don't know Siemens communication protocol.
Okay. Next question, Todd, is where would you not recommend placing this detector? What types of environments or fire situations?
I think that the biggest situation, or the best answer to that is, I think a lot of people, they first hear about this detector and they think, oh, it's meant to go anywhere. I can use this in any application. And the risk to that is somebody puts this in an extremely dusty, dirty environment. While it would operate in that environment, you're constantly going to be cleaning this device. It really wasn't designed for, say a paper processing plant where there's a lot of airborne dust and particulate, because while the device, would recognize that and not go into alarm, you're also going to clog up the photo chamber very quickly, and you're constantly going to be in maintenance mode on these devices. So any really harsh, dirty environment, these aren't suited for. They're obviously designed for an indoor application, so no outdoor breezeways and outdoor elevator lobbies and that sort of thing. They're just, they don't have the UL listed temperature range to operate in those environments. But, again, in your traditional conditioned spaces where you would put a traditional photoelectric or ionization detector, for the most part, this device is perfectly applicable.
Okay, good. Todd, I think that's it for questions. There's no more hands raised, and that's it for text questions. So on behalf of System Sensor, I want to thank you for joining us today. Remember, we'll be sending out a brief survey in about an hour, and you'll also be able to answer additional questions on this product in that survey, and we would really appreciate you filling that out. And if you have an interest in carbon monoxide detection, be sure to join us for our webinars covering that topic next month. More details will be available online at systemsensor.com in just a few days. I want to thank you for joining us, and this does conclude our webinar. Thank you.
All right, thanks.